Hello everyone, welcome to my Global Azure Bootcamp virtual session for 2020. My name's Sam Cogan. I'm a solutions architect for a company called Willis Towers Watson. I'm based in the UK and I'm an Azure MVP. So today I'm going to be talking to you a bit about ARM templates and in particular some of the more advanced techniques and tips you can use to take advantage of some of the features of ARM templates. I've been using ARM templates now for probably over 5 years since they were first introduced in Azure, to be able to deploy infrastructure ranging from simple storage accounts to complex multi-VM, multi-service environments. And so along the way, I've had to battle with some of the complexities of ARM templates, some of the issues, and I've come up with a number of different ways to work around these and to best utilize the system to get what I need. So in today's session, I'm going to talk about some of these features, some of the ways I've used ARM templates, and some of the techniques that might help you improve your ARM templates and make better use of them. In this session, I'm going to assume that you have seen ARM templates and worked with them a little bit before, so I'm not going to explain the basics of what ARM templates are, what they're used for, or how to create and deploy a resource. If you are just beginning your journey with ARM templates and want to get more information on that, then there are plenty of resources both on the Microsoft website and also on my website, including a recently launched video series I'm doing called ARM Template Masterclass, which will take you through that from the very beginning. I blog about Azure and particularly ARM templates at my website, samcogan.com. All of the code samples and demos we do in this talk today are going to be on GitHub as well, so you can pick those up at my events repo on github.com/sam-cogan. And I'll put a link in the notes of this video as well. So with all that out of the way, let's get started looking at some of the techniques and tips that are going to help you with your ARM template journey. So the first topic we're going to talk about today is functions. The ARM template language has a number of built-in functions in it, and you probably already use some of these. For example, concatenate is one that is fairly common in nearly every ARM template that allows you to concatenate strings together. But there are a whole load of functions, and I find that many people aren't actually taking advantage of some of these functions that could help them with their templates. So let's look at a few useful ones. For example, list keys is one that not many people are aware of. This allows you to actually list any keys that come out of your resources you create. So if you create a storage account, you can use list keys to actually pull out the storage account key, which you can then use in other resources. Say you had a web application which needed to talk to the storage account. You can use list keys to grab that key and use it in those app settings. We've got a whole load of array functions that allow us to manipulate arrays. So if you're passing in, let's say, 2 different array parameters and you want to use them in a resource, you want to stick them together, you can use things like union and take to take those arrays and merge them together or take individual items out of them. We have a whole load of logical and comparison operators, which are useful if you're needing to do some sort of comparison between objects or parameters or so on, and they come in really useful when we look at doing conditional options, which we'll look at later in this session. Let's hop over now into VS Code and look at a couple more of these in action in a template. In the first example here, we're looking at naming a storage account. So as you may know, storage account names have to be globally unique. There can't be another storage account in the whole of Azure that has the same name. This can be a bit of a pain when you're trying to name storage accounts, especially if you're trying to do it in automation without any interaction. So what we're doing in this template is we're using a function called unique string to actually help us generate that name. Unique string, as the name suggests, generates a unique string. But this function takes a parameter that helps you actually generate a consistently unique string. You don't want just a random letter generator here, because that will mean every time you run the template, you'll get different values back. And so this would result in you creating a new storage account every time you ran the template, even if that's not what you wanted to do. So instead, unique string will generate the same value so long as it's provided with the same seed. So the value you're passing into the function is some sort of string that is used to seed the command to help it generate the same value each time. And so what we're passing in here is the subscription ID. So if we run this template against the same subscription, we will get the same unique string back. You don't have to use subscription ID. You could do it with the resource group ID, and so it would be unique for each resource group. You could do it with a region ID, so it would be unique per region, whatever you wanted to use as your key for generating the unique ID. What I'm then doing is concatenating that with my actual storage account name that actually explains what the resource is, to hopefully get me a globally unique name for that storage account. In this next example, we're looking at how we can improve on our naming conventions for resources. So here we're creating multiple network interfaces based on a loop. And so we're using a number at the end of that. Someone I work with is very particular about the fact that the numbering at the end of these sort of resources should have the same amount of digits. So we're using the pad left command, which is one of the string functions, which can pad a string with a value. So in here we're saying we need to pad the copy index, and then we're passing 1 into the copy index so that we want to start that numbering at 1 rather than 0. And then we want to pad that to make sure there are always 2 characters. And if there aren't 2 characters, then we should pad it with a 0. And so we're always going to get our network interface names with 01, 02, 03 on the end of them. So for our last example, I mentioned previously there was the list keys function which allowed you to get storage account keys. Well, generally it's not a great idea to use a storage account key for hooking up to things like web applications or passing out to people. Instead, you want to look at using a SAS token. But the problem with this is that you used to have to generate this manually or outside of your template. Well, there's a new function called List Account SAS, which will actually allow you to generate your SAS token as part of your template. So if we need to do what we said before, and we've got a web application or a function that needs to talk to a storage account, now we can use List Account SAS to generate a SAS token for that storage account. And we can pass in all sorts of things about, validity dates, IP restrictions, all the usual things you can do with SAS tokens. We can pass all those in and then generate a SAS token as part of our template. So we can then use that in a resource we create later that needs to be able to access that storage account. So that's a pretty useful function if you need to talk to storage accounts. Moving on to number 2, but still looking in the area of functions, we've got user-defined functions. And this is something that I don't think many people know exists. It's of limited usefulness, but it is something that you should be aware of and maybe something that could help you. So ARM templates does let you define your own functions. So instead of using the built-in ones, you can create your own functions as part of your template and use them throughout your template. The limitation with user-defined functions is that you're limited to using the built-in functions as part of your function. So you can't create any brand new logic that didn't already exist in a built-in function. But what you can do is use those built-in functions to create a new function, if that makes sense. So one of the most common reasons that I use this is to simplify something that I'm doing a lot in my template. So if we look at the example on this slide here, we're using a lot of built-in functions to generate what is effectively a name. So we're using concatenate to actually stick some strings together. We're using toLower to put it all lowercase. We're replacing some values in the string, and then we're using take to take something out of an array as well. It's a fairly complicated value. If we're doing that once, then that's perhaps not an issue, but if we're using that more than once, then writing this out every time can be a pain. It also makes it pretty unreadable. So looking at that value, if I was coming to that template fresh, I have no idea what that actually is supposed to be doing. So we can use user-defined functions to simplify this, to put all this logic inside a function which has a name which indicates what it's doing, and then use that function throughout our template. All the complexity is contained within the user-defined function. In the rest of our resources where we use it, it's simple. There are a few other limitations with user-defined functions that it's worth being aware of. So firstly, you can't access any variables that are in the rest of your template inside a function. You can only use parameters that have been passed into the function. So a function itself has its own parameters you can use. You can only access those parameters, not any parameters outside of the template. Now you can pass those parameters and variables in to the user-defined function as parameters. That would solve the problem, but you have to explicitly do that. User-defined functions also can't call other user-defined functions, so you can't have any sort of nesting or trees of functions. And user-defined functions can't use the built-in reference function as well. So to see a practical example of this where it might be useful, let's go and have a look in VS Code. So here we've got an example of a UDR that I created to do what we talked about previously, which is create a storage account name. So the first thing we see is there is a new section at the top level of the ARM template called functions. This is where all our user-defined functions go. Inside that, we are defining our function, and we need to set a few values. The first thing is the namespace. So all our functions need to sit inside a namespace that we create to differentiate them from the built-in functions. You can call that namespace whatever you want, and you can have multiple namespaces if you want, but it might be simpler just to keep all your functions inside a single namespace like I've done here. Next we have a members array which contains all of the functions that we want to create. Then we create our actual functions. We give the function a name, so in this case it's called GetStorageName. We then list any parameters we want the function to accept. So I'm passing in a string prefix, which is the first part of my storage account name. And then we have an output section which returns whatever the function is doing. So in this case, we're firstly using some of the built-in functions to ensure our prefix meets the requirements. So we're reducing it to lowercase, and we're replacing any spaces with dashes and so on to make that valid. And then we're concatenating that with the unique string function to be able to stick on a unique value at the end, which will generate a unique storage account name. This function is now ready to go. So later on in the script, we are actually going to use this by calling the lambda_toys.getStorageName function and passing in a single string. So now if we're creating multiple storage accounts name, we can use this function over and over. We don't have that complicated set of built-in functions in every name line. We're just calling getStorageName, and it's very easy to tell from that this is what we're doing is getting a storage account name because it's the name of the function. Number 3 is nested templates. ARM templates are able to call other ARM templates as part of the deployment. And so what this allows you to do is build up a hierarchy of templates calling other templates. So you could, for example, have a master template that then calls out to sub-templates, or, as suggested in the diagram on this slide, you can actually split up your templates into more reusable modules. And so that allows us to define a particular piece of work within one template, distribute that to our team, and have they use that template as their module for a particular resource. So let's take an example of deploying an Azure SQL Server. That's a single resource, but there are lots of configuration things you can do for a SQL Server. You can turn on threat detection, you can configure encryption, and those sort of things. So maybe you've got a corporate standard for that. So you could create a template that does all the things you need to do. That could then be your Azure SQL module, which you then pass out to your team, and whenever they want to deploy a SQL Server, they write their own top-level template, but that then calls out to the SQL Server template when it needs that. So you can build up a library of reusable components. You can also do things like storing configuration in templates. So you can import a particular configuration template for the resources you're looking to deploy. So let's have a look at how nested templates actually work. Let's have a look at how nested templates work. There are two ways you can actually define a nested template within your top-level ARM template. You can either do it inline, or you can call out to an external resource. So the first option we've got here is doing it inline. This is where we create a nested resource, and this is just like any other resource in an ARM template. It just has the type of Microsoft.resources/deployment. And then inside that, you specify things like the deployment mode, and then you specify any parameters, variables, resources that are in that template. This is all declared inline in your top-level template. So effectively, you're creating a template within a template. So the example here, we are using this nested template to deploy a storage account. Generally, this method isn't used very much. There's one scenario which we'll talk about in a minute where it might be useful, but for the most part, people tend not to use the inline template because you don't get any of the benefits of modularization or reuse with that. You're effectively just writing a template inside another template. You've still only got one file. So the second option is the one down here. And this is where we actually define the second template as an external source. So we're using the same resource type, Microsoft Resources/deployment. We've got the same properties like the mode, but instead of the actual template being defined, we're defining a template link section. And this allows us to reference a file somewhere else. Now it has to be somewhere reachable by the ARM fabric when it does the deployment. So some of the most common places to put this are things like Azure Storage, GitHub, so you can access them using a GitHub raw URL, or any other sort of Git provider that has that functionality to be accessed by the ARM fabric. Not from the machine that's doing the deployment, but actually from Azure when it runs your raw template for you. As with the inline template, we can pass in any parameters we want to call that, and then that will go off and it will fetch the template from wherever we've stored it. So one of the key things you need to work out if you're going to use nested templates is where are you going to store them, because you are responsible for making sure that your nested templates are where your main template expects to find them. They're accessible. Any security is usable by the ARM template. So the most common way I do it, where I need to secure my templates, is I will put them in an Azure storage account, and then I will use a SAS token as part of my template link URL to actually access them. And you can pass that into your top level template as a secure string or similar, or even pull it straight out of Key Vault. So let's now quickly look at an example of a nested external template in use. So here we've got a template where we're deploying a load balancer. The load balancer is created in our top level template, but our load balancer needs a public IP address. And so the public IP address is in a separate nested template. Let's imagine this is a module for creating IP addresses. So inside the main template, the first thing we call it out to is the nested template, giving it a URL of the template that's stored on GitHub, and then passing in a parameter for that as well, which is the name of the IP address. Now, if we go and look at the IP address template, we can see it's just taking that parameter of name that we expect. It's running a resource creation for the IP address, but then you can also see in the output section, we are actually outputting two items from the IP address. So the resource ID for the IP address and the DNS label that's been assigned to that IP address. We're outputting those because we're then going to use those in our main template. So you can see here, when we look at the actual load balancer resource, the public IP address that's assigned to the load balancer for the ID, we're referencing the output of that nested template to use that to assign that IP address. I mentioned earlier that writing your nested template inline is not something that's used very often. However, one scenario where you might use it is where you're not actually interested in the benefits of nesting from a modularization and reuse perspective, but instead you're looking to do a cross-subscription or cross-resource group deployment. So sometimes you want to deploy a ARM template, and when you run the deployment command, you're pointing it at one resource group where the majority of your resources are going to go, but there is some other resources that actually need to be deployed to a second resource group, or even a resource group that's in another subscription. The only way to achieve this is through the use of nesting, because everything that's in your top level template is going to get deployed to the resource group that you used when you ran the deployment command from PowerShell or CLI or so on. So to deploy to a different resource group or subscription, you need to use a nested template, because the nested template object, so the resources/deployments object, can accept a resource group and a subscription ID. And this then allows that second template that's being called by the first to be deployed to a different location. So if we have a look at this example here, you can see I'm using the same type, but I've got this additional two properties of resource group and subscription ID. So when it gets to this part of my template, it will run that nested resource and it will deploy to the subscription and resource group that I've defined here. Now you absolutely can do this as an external template as well, but sometimes if the only thing you're trying to achieve is actually to deploy to a different location, then going through the effort of actually finding somewhere to host that file and so on is not really worth it if you're just doing a simple deployment and just want to do it into a different location. And so maybe that's why you might use an inline template. Up next, we've got T-shirt sizing. So this is a concept that helps you deal with complexity of configuration while also maintaining the ability for users of your template to make choices. So every resource you deploy in an ARM template is going to have configuration options. Often these will allow you to put in many different options depending on what you want to choose. If you're allowing your users to pick some of these options, then you're going to have to provide them as parameters into your template. The problem with that is as you have more and more choices, the amount of parameters you're actually going to need in your template becomes more and more, and you get a very, very complex interface to your template that a user, when they want to deploy it, now has to provide all of these values. So the concept of T-shirt sizing is something that allows a user to pick from a predefined list of settings, but only having to make a single or a couple of choices rather than having to pick every single one. So you define what your sizes look like. So you might have a small, medium or large. It doesn't have to necessarily relate to size. You can do any sort of configuration options, but you predefine a set of options, a small, medium, large, development, test, production, whatever you want to call your selections, but you offer them, and each selection has preset variables. So the only parameter you're now passing into the template is your choice of predefined option, and that then allows for the selection of all the different components inside your template based on that. So your template is much simpler in terms of the interface, but the user is still able to make a choice. So let's have a quick look at an example template to see how that works. Here's an example of using t-shirt sizes in a fairly complex template. So we've got an ARM template here that is intended to deploy a highly available Redis cluster using IaaS VMs in Azure. So this has a lot of configuration options that could be offered in terms of the sizes of the VMs, the number of VMs in the cluster, cluster configuration, and so on. But to try and keep things simple, we're utilizing the t-shirt size option. So if we look at the parameters of the template, one of these is t-shirt size. And this accepts 3 values, small, medium, or large. And we've defined that in the allowed values section, so that's all that can be provided. So a user is going to pass one of those options in as their choice at deployment time. And then if we look in our variables section, we have our t-shirt sizes defined. So we have here t-shirt size small, t-shirt size medium, and t-shirt size large. And each of those within the JSON object then has all the different configuration options that make up this size. So a small cluster is using the A1 VMs, whereas a medium uses A2 and a large uses A5. We're defining the number of masters and slaves based on that, whether or not the arbiter is enabled, and other configuration options based on a single choice. What we then do is we create another variable called cluster spec. And so this basically just concatenates the word t-shirt size with the selection made in the parameter section to create t-shirt size small, t-shirt size medium, or t-shirt size large, which is the name of those variables containing all the selection options. Then if we actually look in our template itself where we need to use these options, we've got an example here where we're defining the size of the VM to be used in our resource. The syntax we're using here is looking up variables cluster spec, which is that t-shirt size, small, medium, or large, dot the actual value of the inside the JSON object. So it will now go and look up that value from inside the appropriate object based on what we passed in to that t-shirt size parameter. Now, one thing you will notice is that in Visual Studio Code, it has highlighted that as an error. Unfortunately, the ARM template extension syntax highlighting doesn't actually understand this method and so does highlight them as an error. The template deploys absolutely fine, there's no issues with it, but unfortunately the syntax highlighting hasn't caught up with that. There are various other points in this template where we're using the same syntax to go and pull out the different options within that JSON object for the size we've picked. So now our users can use this template and they can just pick the size, a single option, so small, medium, or large, and it will be configured based on all those pre-selected options we have decided that compose a small, medium, or large Redis cluster. Number 5 is conditions. So for a long time in ARM templates, we didn't have any sort of conditions. The only way we could do any sort of conditional logic was through the use of nested templates and a bit of hacking with URL paths. Not really a great way of doing things. With the introduction of conditional logic, we're now able to do proper conditions within our template. So conditional logic in ARM templates comes in 2 forms: conditions and if. So the first, conditions, allows you to make a choice at the resource level. So a condition defines whether or not an entire resource should be deployed. So this is the first option in the slide here. Got a condition parameter, and we're passing in a value using one of the built-in functions, equals, to get a true or false value out of this statement. And based on the result of that, we will choose whether or not to deploy the whole resource. The second option, if, is for things inside resources. So we're now not looking at whether or not we deploy an entire resource, but we're making a choice inside our resource as to whether we apply a particular property or what the value of a property might be. Now it's important that we have both of these options because there are going to be these sort of choices we have to make at different levels within our template. Let's look at an example where we're using both of these options. In this template, we've got an example of using both conditions and if. And so what this template does is it's pretty simple. It just deploys a network card to a virtual network, and it has a parameter that is passed in that defines whether or not this network card should have a public IP address or it should just be purely private. Up here you can see the parameter called network interface type that accepts 2 values, public or private. Based on that parameter, we need to make a decision as to whether or not we create a public IP address and assign it to that network card. And so we need to use both if and conditions. The first thing we need to do is here, which is actually, do we deploy the IP address object at all So if we're doing a private network card, there's no point creating a public IP object. It's an extra resource, it costs us some money, we shouldn't create it because we're not going to use it. So here we can use a condition because it's a top-level resource choice we're making. So we're adding a condition option here, and then we're using the equals function to say if the parameter that we passed in called network interface type, its value is public, then the condition is true and we will deploy it. If it's anything else, in this case private, then it won't get deployed. So that's pretty straightforward. That will determine whether or not the top-level IP address resource is created or not. Now we've dealt with that public IP object, but we have a second challenge here because there is an option on the network card whether we need to define the public IP address object at the network card, to assign it to the network card. If this is a public interface, then we need to assign that, and if it's not, then we need to not assign that. But that isn't a top-level resource choice, that is a property of the actual network card interface. So here, you're going to use condition, we're going to use if. So here's the public IP address property, and we can set the value using if. So if it's just like a normal function, it takes some values, and so we're saying if, and again we're using the equals parameter to say if network interface type equals public, then we will set the public IP address property's value to this variable, and we'll come to that in a second. If it's false, then we will use this JSON function to pass null. So JSON null, that will just effectively give it a null value for that property, so nothing will be assigned. Now, skipping back to the true option, you can see here we're not actually giving it the ID of the public IP address, we are passing in a variable. Now, you can just pass in the straight resource ID here, but what I've done is define this as a variable up here in the variables section, because this makes it much easier to read, because we're not trying to define a JSON object in line, we can do it in the variables section and expand it properly and make it easy to read. So there's no reason why you can't do it in line, it's just easier to read, I find, if we define it in the variables section, particularly if you're going to do more complex objects that have lots of properties and so on. So if it's true, we assign this variable. If it's false, we assign null. And so now we've got a deployment which will take one parameter and decide whether or not to create all the public IP address parts, so the actual IP address and the assignment, or not, based on that value using conditions. Number 6 is deployment modes. So you might not be aware, but there are actually 2 different modes you can deploy ARM templates in. Pretty much everyone I speak to is using the default, which is the incremental mode. That's what you get if you don't specify anything when you do your deployment. Incremental mode means that when you deploy your resources, the ARM template will run if there's anything already in the resource group you're deploying to that's not in the template, it will be left alone. If there are things already in there that are in your template but are configured differently, then the deployment will reconfigure those to match what's in your template. But anything that was already there that's not defined will be left alone and not touched at all. The other deployment mode, which is called complete, assumes that everything within the resource group is owned by your template. So if you deploy this and there's something in your resource group that is not in the template, then it will get deleted. The deployment of this template will work to ensure that the content of the resource group looks identical to what you've defined in the template. Now, obviously, this can be fairly dangerous if you have somebody doing manual configuration or creating resources in other methods in that resource group, because they will get deleted. So you do have to be careful about its use. But if you're trying to ensure that what you deploy is what you get in Azure, then this can be quite a useful tool, because it will ensure that everything reflects exactly what's in your template. Another reason why you might look at using the complete mode is another bit of functionality that not many people know about, which is rollback. ARM does support rolling back deployments if they fail. There's a flag you can use on the deployment command, which will have Azure roll back to the previously successful ARM template should your deployment fail. But this only works if you're using complete mode. The rollback needs to ensure that what's in the resource group matches what's in the template. If it was using incremental, then it might be things in there that it's not aware of or doesn't know, hasn't configured those, and so it can't do that. So the only way you can have rollback in place is if you use the complete mode. So if you're in a position where you want to do completely fully automated deployments using your ARM templates and you want to ensure that what's in Azure matches exactly what's in your template, then using the complete deployment can help you achieve that. If you want the functionality of rollbacks, then the complete deployment will also help you achieve that. Number 7 is deployment scopes. For a long time, the only scope we could deploy ARM templates to was the resource group. The new Azure RM Resource Group Deployment command was the one we used, and that deployed all your resources into a specific resource group. This was fine for a large amount of what we were doing, but as more and more resources came that required to be deployed at other scopes, we were a bit stuck. And so now Microsoft have introduced 3 other scopes that we can run our deployments at to allow us to create those resources. So we can deploy now at the subscription scope, at the management group scope, and at the tenant scope. And so this allows us to have our templates deploy even more resources. So one of the biggest pushes was for the subscription level scope, and that was to allow us to deploy things like resource groups. Previously, we could deploy everything in a resource group, but if we wanted to create a resource group as well, we had to create that outside of our template using PowerShell or CLI or something like that, and then run our ARM template to deploy into that. So with the introduction of subscription level deployments, we can now deploy a resource group as well. We can also deploy things like policies and RBAC permissions at the subscription scope, as well as at the management scope and even the tenant scope. The choice of scope is determined by how you deploy your template. So there are 3 new PowerShell commandlets that can be used to deploy your resources. And so if we want to deploy it at the subscription scope, then we would use the new AZ subscription deployment command to trigger our deployment at that scope. Now this adds a bit of complication because quite often you actually want to deploy resources at multiple scopes. So let's take the example we talked about before. We want to deploy a resource group, and then we want to put resources in that resource group. So we need to deploy the resource group at the subscription scope, and then the rest of the resources at the resource group scope. Because our highest level is subscription, we need to run our deployment using the new AZ subscription deployment command. So that's how our top level template will work. We will configure it to run using that command, and that will then go and deploy the resource group. Now, to deploy our resources into that resource group, we have 2 options. We can't just put them inside the same template because that will all be at the subscription scope. And so either we run a completely separate deployment next, which is a bit of a pain, or we use a nested template. So you can have a nested resource in your top level template that deploys at the resource group scope, using the resource group you just created in the previous scope. Not quite as seamless, but it does allow you to have a single deployment that does deployments at each different scope. And if you wanted to go through all 4 levels, then you could trigger your actual deployment at the tenant scope and then have nested levels going down through management group, subscription, and resource group. Automated testing is not something that most IT pros usually think about, but now we're writing our infrastructure as code, we can actually test it like code. And so ARM templates are something we can write tests for to hopefully try and find issues with our templates before we actually deploy them. Now, there are a number of test frameworks that you could use for this job. What we'll look at in the demos you'll see in a minute is a tool I'm using called Pester. So Pester is a testing framework for PowerShell. So this means I can write my tests in PowerShell, which I'm pretty familiar with. I don't have to go and learn any sort of other programming language like C# or anything like that. I can do it in PowerShell, and I can write tests against my infrastructure that I can run at a regular basis, or perhaps whenever I make changes, or before I want to do deployment, to hopefully try and catch errors quickly in a test rather than when I actually deploy resources. This can save me time, but it can also save me money because I'm not actually deploying real resources when I run my tests. Now, there are 2 sorts of tests we're going to talk about today. The first is looking at the actual template, looking at the content of the template and validating things like, is it valid JSON? Do I have the right sections in my template? Am I missing any resources that I wanted to create? Those sort of things. So those are all things we can test just by looking at the content of the template. The second sort of test is a bit harder, and this is where we want to actually look at, is the template deploying what I think it's deploying? And so for the most part, you can't actually tell this just by looking at the template alone. You are, at the minute, going to have to deploy the resources into Azure and validate what you see in Azure matches what's in the template. Now, this is hopefully going to improve in the future when we look at section 10 of this, which is the what if command. That's probably going to help us with our testing world. But for the moment, if we want to test what we've actually deployed, we're going to have to deploy it. And that can be a bit of a time-consuming and potentially expensive task. So you need to think about what the purpose of your testing is, what you actually want to validate, and whether those sort of tests are worth your time, or whether you want to stick to the more template and syntax approach where we're trying to spot errors in our actual code before we try and deploy them. So let's have a look at some of this testing in action. We've taken a very quick look there at how you can create tests for your ARM template. There is an awful lot you can do with testing, and much more than we've got time to show today. So if this is a topic you're interested in, I would recommend checking out my blog, where I do have a few more articles on doing this in more depth. Here we have an example of a set of tests that I've written to test my ARM templates before I deploy them. And so, as I mentioned, this is using Pester. We don't really have time today to go into Pester in great detail, but just to give you an idea, this is how you structure a Pester test. So you have a describe section, which is just basically a container for a certain set of tests. You have context, which is another divider inside your describe. And then you have your it section, which is where you're actually running your tests. So you define your test using a syntax of something like it has a JSON template, or it has a parameters file like we have here. You give it a name that reads like a test case effectively. And then inside that it section, you have your actual tests using a load of assertions that Pester provides. So, for example, these ones here using should exists, and then a bit further down we're using should be to do a comparison between two objects, and so on. There's a whole load of assertions that Pester provides that you can use to do your actual tests. So for the actual content of the test, the first three sections we have here just deal with checking that files that we expect to be with the template are here. So it checks for the actual template file, the parameters file, and a metadata file, and checks that they exist. That's our first step. So we'll get an error if we're missing a parameters file, for example. Next, we're doing something a bit more complicated, which is checking the content of the template for two things. Firstly, to make sure that it actually compiles to valid JSON, and secondly, that it contains the sections that are expected in an ARM template. You see here we're defining an array of expected properties, so an ARM template should include a schema section, a content version, a parameters, variables, resources, and outputs. So if any of those are missing, we will fail that comparison test because they're not in our object. The second thing we're doing here is we're using convert from JSON. So that takes the content of the file and tries to run it through the PowerShell conversion command to actually convert it from JSON into a PowerShell object. If the file is not valid JSON, then this will fail. And so this will give us a test to check that we haven't missed any commas, brackets, the usual things that we would find if we'd actually written invalid JSON. So this will catch any of those syntax errors very early. The next test in here is more specific to my actual template. So what I'm doing is checking that the template contains the resources I expect it to contain. So an automation account, virtual network, public IP, and so on. This is something you would have to tailor to your specific use cases. And this is one of the things with tests. When we're writing actual templates and code, we aim for making them more generic and reusable. With a test, you will often find you need to make them very specific to your use cases. And so here I'm testing for my particular resources, and if those resources aren't defined in the template, then it will fail, and that will let me know that I haven't defined a resource that I expected to be in there. The final test in here is to run the test AZ resource group deployment command. So if you've not used this command, this allows you to actually run your ARM template against the pre-flight API for when you deploy it, but not actually deploy the resources. And this will highlight any errors in the script around resource providers and anything that would be picked up in the pre-flight tests. And so by using this in our template, we can check that as well before we actually deploy anything. Now, the one limit with that command is that the resource group you're running against has to exist. Even though you're not actually deploying anything, the resource group needs to be there. And so one trick we're using with Pester is this before all and after all section, which allow us to run some operations before the tests and then run some cleanup after the tests. So in the before all section, we're creating a resource group, and in the after all section, we're actually removing it. So let's go ahead now and run those tests. These do take a little bit of time to run, mainly because of the resource group creation and deletion. Particularly deletion seems to take a little while. But we can see already that we've got some tests that have passed at the beginning, and then we have one failing. That was intentional. That file doesn't exist. And then the rest of the tests all pass. So you can see the test syntax is fairly simple. It's just green for pass, red for fail, a plus and a minus. But we can get a quick visual view of this test. You can also do things like hook this into your build pipelines. You can have this give you an exit code of the number of failed tests, so it will give you a 0 if everything passes, and you can hook your build pipeline into this and even export the Pester tests as NUnit results that can be read by things like Azure DevOps Test Reader to show you the test results as well. So you can build some pretty complex testing in here and run it as part of your regular pipeline whenever somebody commits, whenever somebody puts a pull request in, whatever you want to do. The second test in here, which I'm not actually going to run, but we can just see what I've done here, is more about validating the infrastructure. This test has to be run against infrastructure that has been deployed. But what this is doing is going to talk to the ARM API through PowerShell and getting the information about our deployed resources, and then using Pester to validate those against what we expect those resources to do. So, simple one here, the networking tests, we are getting the VNet information from using Azure PowerShell, so we have a VNet object, and the first thing we do is check that it's not null. Has a VNet actually been created with that name? Then we can get a bit more detailed and look at things like the subnets we expect exist, and the subnets have a specific IP range. Then we can look at virtual machines, make sure they exist, make sure they're the right size, make sure they're in the right region, and so on. So you can make these tests really detailed. You can go and check all of your individual resources. You can also do things like checking against a policy you might have around security, so making sure no VMs have public endpoints, everything's got NSGs supplied, and so on. I've got a few examples of these sort of audits and infrastructure testing on my GitHub repo, so if you want to go into any of these in more detail, feel free to have a look. As I mentioned, hopefully with the what if command, we'll be able to do something a bit different with these sort of tests and actually not have to deploy them, but rely on the what if command to tell us what's going to happen in our deployment. The last two features we're going to talk about today are both new features for the ARM platform, and both of these are actually in preview at the moment. So if you want to try them out, you may find you need to sign up for the private preview, depending on when you're watching this, or they may have gone into public preview, but they are not GA at the moment. But I thought it was worth talking about them because they are some very substantial changes that will be beneficial to a lot of people. So the first one is deployment scripts. This feature allows you to run scripts within your deployment. So you can run either PowerShell or CLI. And so this is a feature that people have been asking for a long time. So ideally, if you're writing ARM templates, you want to deploy everything declaratively using the actual ARM template resources. In an ideal world, that would be all we did. But unfortunately, there are some things we just can't do with ARM templates, or there are some things that we actually want to reach out beyond Azure and do things that are not encompassed by the Azure Fabric at all. And so what deployment scripts allow you to do is to run a script that, as part of your deployment, but that can then reach out to those resources and do those sort of things. So some examples here are things like creating Azure AD users. There's no ARM template for doing that at the moment. Performing data plane operations, looking at storage blobs, queues, those sort of things, creating objects in there. Looking up IP addresses outside of your current deployment. Those sort of things. Anything, to be honest, that you can think of that you can write in PowerShell or CLI that is accessible to your deployment. And so how this feature works is that when you create a deployment script, you declare it in your template using the ARM syntax. What happens when that gets run is that behind the scenes, it's going to go and create an Azure container instance for you to actually run the script in and a storage account to work with that. These resources will actually appear in your subscription, but they're created for you by ARM when it runs your script. Now, this was theoretically possible before the implementation of deployment scripts. You could have your template go and create a container instance and pass it some values to run as a script. The big difference here is that this is integrated into the ARM template itself. So previously, if you did what I mentioned there, the ARM template would deploy the container and then it would move on to the next step. It wouldn't wait for the container to run. It wouldn't pay any attention to the actual result of the container running. In this implementation of deployment scripts, it actually does wait for the container to do whatever you've asked it to do, and the exit code will be fed back into your ARM template. So if your deployment script fails, your ARM template will fail. This also means you can now have dependencies that rely on this script running first before you do something else. So this is a pretty useful tool to allow you to do things that you can't do in ARM templates. It's sort of an escape hatch. But there is one thing you need to be careful of. ARM templates are designed to be idempotent so that you can run them over and over and they will get the same results. So if there's nothing changed, then the ARM template won't do anything. As soon as you add scripts into that mix, which are now imperative and not declarative, you have to be very careful about how you write your scripts to make sure that if you run the same template over and over, that you're not going to do something different every time, because then obviously you can't rely on your template being idempotent. So make sure that you write those scripts in a way that can be run multiple times, and if there's nothing to do, it just detects that and exits out and moves on. Let's have a quick look at how you configure one of these scripts. Here we have an example of using a deployment script within a template. So this is just, again, another resource. This time it's Microsoft.resources/deployment scripts. And there's a few resource-specific things we're going to define. Firstly, kind, which has to be either Azure PowerShell or Azure CLI. That determines the type of script you're trying to run. So if your script is going to be talking to Azure resources, then you're going to need to use a managed identity. That's the only option it supports, is a user-assigned managed identity to give your container instance an identity that can actually go and talk to the Azure API. Then we've got a properties section, which is defining a few things like the PowerShell version, any environment variables, and we have this force update tag as well. All this does is provide you with a hook to have something in your template that changes when you run it, to trigger it to actually rerun the script. If you don't, then potentially ARM will see there's nothing to do because the resource hasn't changed and so won't rerun it. Then we get into the script content itself, and this is where we define the actual script we want to run. We put whatever we want in that script, and then we have a few other options at the end. We have a timeout window, so how long we want this to be able to run before we forcefully time it out, and a cleanup preference, which allows you to define what happens after your job runs. So do you want it to delete the container instance and the storage account from your resource group? Here we've got it set to on success. So if it's successful, it will clean up after itself. If it fails, it won't, and that will give us some opportunity to go and debug what happened. We're using the script content section here. There is also the choice to have a script URI option instead, so you can put your script out on GitHub or Azure Storage or whatever and decouple that from having to write that in line with your template. Once we fill all those in, we can then use it like a normal resource. So when we run our deployment, this resource is going to get triggered and it will run our script for us and do whatever we've defined in the script. As I mentioned, we do have to be careful to make sure that this script is idempotent and we can run it over and over again if we need to. The final item I want to cover is again another new feature, and this is the what if feature. So if you've ever used tools like Terraform, you will have noticed that this has a very nice feature called Terraform Plan, which allows you to go and run a plan against your scripts to determine what's going to be deployed and what your template is going to do before you actually run it. So you can see that it's going to create 6 new resources, delete 2 and edit 4. That's a very useful tool for being able to see what you're going to do, but also potentially run some sort of testing or validation before you deploy your resources to understand that it is going to do what you want. Well, what if is the implementation of this feature within ARM templates. So you can now run the what if command against your ARM template and get an output that will show you what is going to happen when you deploy that template before you deploy it. So that you can validate that and say, yes, that's what I want, let's do it, or no, I wasn't expecting that, let's go back and rework a template to make sure that doesn't happen. Again, this is in preview at the moment, but it is available for you to use, so you can go and install the updated module and try out what if to see if it works for you. Let's see this in action now. Now, as I mentioned, the what if command is in preview, and one of the reasons it is still in preview is around noise. So as you probably saw from the demo, there's a lot of information that comes back from the what if command about what's going to happen. And a lot of this is to do with comparing what's currently in Azure with what you're asking it to do. Now, sometimes what you might find is that the parameters you send to a resource are less than what you get back from a resource. So quite often if you deploy a resource in Azure, there are some values that are calculated or determined by the fabric. Things like e-tags, deployment time, any sort of metadata about the resource. And so what you might find is if you run what if, it might tell you there's a change because one of those items has changed, but you have no control over that. That's not something your template's doing. That's just because the information you are sending to the ARM fabric is less than what you get back because of all these other properties. And so one of the things the ARM team are working very hard on is how do we eliminate that noise? How do we make sure that we mark these tags as calculated or not something the user has control over so that you don't get this noise and so that your template comes back and says, no, there's nothing to do when there really is nothing to do, not because some information has come back that it wasn't expecting. And so there is a GitHub repo that the ARM team are collecting information about where you see this type of noise. And so if you do use the preview and you do find noise in your commands that you think should be got rid of, please do go and raise an issue in this GitHub repo. I'll link it in the notes below the video. Please do help the team clear up that noise. To use the what if command, we need to have the preview version of the PowerShell commandlets installed, which I've got here. This isn't actually a new command. When this was originally previewed, it was, but after a lot of complaints, Microsoft have changed tack on this and have now integrated this into the actual what if parameter of the new Azure Resource Group deployment. So it's not a separate command, it's a flag that you can run on your existing deployment command, which I think makes sense given that PowerShell already had this what if flag that was used by a lot of other commandlets. So to run this, we'll do new Azure Resource Group deployment. We'll provide the resource group name and the template path as we normally would, and anything else like any parameter files or similar. And then we're going to add on the what if flag. And if we run that, it takes a little while because unlike the Terraform approach where it maintains a state file which it uses to calculate what the difference is between what you're deploying and what already exists, ARM doesn't have that. So what it's actually doing is going off to the actual ARM API and querying what actually exists in Azure right now. So this potentially can take a bit longer than the Terraform approach, but this is going to be actually exactly what you have deployed, not even if somebody has manually gone and amended what's in Azure since you last deployed. Once that runs, we will then get an output back which is color-coded that will show us things that have been added, removed, or changed, and give us a summary of that information. In this example, we're just adding new resources to an empty resource group, so it's all showing us things that are going to be added. If we though go ahead and run a second command, which is looking at an existing deployment and amending that, if we run that through, again, it'll take a little while when it goes off to the API. We can see here that we're actually getting some additions and some updates of existing resources. By default, when you run this, it's going to give you all of the information about the resources you're looking to amend, add, or delete. And this could be quite a significant output. You can use the what if result format parameter to specify a cut down version. So this is the resource ID only option. And what that will do is it will just show us the resource IDs that are being changed or added or deleted rather than every property for those resources. So it'll give you a much more cut down review. If we run that, you can see what I mean. So you can, if you want, get a detailed view or you can get a cut down view. Another option you can do is instead of using the what if flag, you can use the confirm flag. And what this actually does is it will go and run the what if command and it will give you the results, and then it will ask you if you want to continue. And then if you enter yes, it will then go ahead and run the deployment. So you can use that as sort of a pre-deployment test, and then if everything's okay, you can say yes and it will go ahead and deploy it, much like the Terraform apply command. As I mentioned, it's important that we eliminate all the noise aspects of this. So if you do use this and you do see any noise that needs to be reported, please make sure you do raise an issue on the GitHub repository. I'll add a link to that below the video as well. And that just about covers all the tips and tricks I've got time for today. Hopefully you found them useful. And if you've got any questions or queries, please put them in the comments of the video. I'll be happy to answer those as you watch them. Please do check out all of the other videos from this year's Global Azure Bootcamp. All the code samples and demos from today are on my GitHub repo, so please feel free to download those and try them out. And please do check out my website at samkogan.com if you want to see other articles around ARM, DevOps, and automation in the cloud. Thanks for watching the video. Hopefully you enjoyed it and found it interesting, and I'll see you next time.